Swayam Prabha. Digital India. Educated India.
Welcome back. So this was the last discussion we left as related to solifluction. Part of that I already discussed. And what is solifluction? Solifluction is a very slow downward movement of wet soil along a slope under the influence of gravity. Now, as I told on that day also, that this is mostly seen in the area where you are having the snow cover, or you can say the ice cover, mainly in the glacial terrain, and this happens during the summer when there is a melting of the snow cover surface, the uppermost surface, and it will be in very slow movement. So, when with an increase in the pore water due to melting of the uppermost soil cover because of the melting of the snow, there will be movement of ground gradually along the slope, and this will result into the formation of a typical lobe like structures, which you can see in this slide also. So, you have in lobate structures which have been seen, we are moving slowly, and this is from the satellite picture which shows the lobe like feature. So, there is an uppermost unit which is saturated with water, and that saturation is because of the melting of snow. So, you need to remember that this type of movement will be seen in the glacial terrains, and this will happen during the summer, where the uppermost part of the surface melts. Now, coming to another one is the soil creep. Soil creep again is a very slow movement of the material, and creep is extremely slow, even slower than the solifluction, and the movement is downward again of a dry superficial material. So, if you see in the section, if there is a bedrock, then also you will be able to see the bending of the succession, as well as you will see a formation of extensional cracks, and either the tilting of the light poles, or you will see the bending of trees also. So, these are the indication of creeping. Movement of the soil occur in the region which is subjected to freeze and thaw conditions. So, this is again a very important point for the soil creep. Then further, it is important, of course, for any civil engineering structures which have been put on such surface. So, we have to be extremely careful before selecting the site. For example, if you see in this photograph, there is a creeping which is taking place, of course, which can be figured out based on the incline or the bent trees which have been shown here in the sketch. So, this is a clear cut indication of creeping of this material, which is an extremely slow movement. It may take years to slip down the surface, or the movement which is occurring along the slope. Another example of the rock creep, you can say, where the rocky succession is getting bent because of the creeping of the uppermost surface. Mud flow again is the movement which is related to the slope material which became saturated, and basically what we are talking about, that the cohesion bonds between the particle is lost. So, as soon as it loses a shear strength, this will move. But here what main important part which plays is the cohesionless material and the saturated material because of high precipitation. So, the saturated material then flow like a thick fluid downslope. Now, the flow stops when the water loses through the seepage. So, the material will be dumped as soon as the material which is saturated lose out the water, or there is an escape of water from the sediments, and that solidifies. Mud floats can occur on very low slope angles because internal particle friction resistance and then cohesion is negligible, and this will happen when you lose out the cohesion bonds between the sediments. It occurs where fine textured sediments and soil mix with water to create a liquid flow. One of the well experienced examples which are also the rapid type of downslope movement of the material, which involves mud flows along with the volcanic ash, which are termed as lahar. And this part I was discussing when we were talking about the volcanoes capped by snow peaks, then you will have this lahar flows. So, slides mainly occurs with a definite plane or the failure surface along which it slips is termed as landslide. So, this part is important. It will move, the earth mass will move along a definite plane or a definite surface. Movement may be along one or more planes, that is multiple planes, where during movement the moving mass may experience considerable deformation. So, when the material is sliding down, it may be deformed. So, this is along a definite plane. It may have one plane or multiple planes, and it will experience deformation. I will show some examples from this area where we have encountered the movement along a definite plane as well as the deformation. The most common slide occurs in clay soil, where slip plane is like a spoon. So, the definite plane, one or more planes may experience considerable deformation, and the surface could be seen as a spoon shape, and this type of slides are termed as rotational slides. The reason is that when there is a mass movement, for suppose you are having a slope here, and if the movement is going to take place along a definite plane, then what you see is that you have this movement, and the material which is moved along this plane will have deformation over here. So, this will be in spoon shape scar, and this scar or the plane will be visible sometime, otherwise it will be hidden. So, rotational slides is one of the example which have a very typical spoon shape surface, and this portion, that is the toe portion, has experienced deformation during the movement. So, this could be resulted from the tensional scars in the upper part of the slope. So, you will come across some extensional or tensional scars in this region, and deformation that is under compression over here. Common after earthquakes or after removal of part of the slope for construction. If you have removed the portion below the slope, that can also result into the rotational slides, and this construction is mainly either you are putting roads or rail tracks. So, this sketch shows the movement along a definite plane here, which is typical a spoon shape, multiple planes, okay. Not the single but two, and this portion is your scar which is exposed, and if you locate here and go and see this portion, you will find an extensional cracks or the tensional cracks, and the toe portion will be under compression because of the movement along this plane. So, because of the friction between the material which is moving on the top along the definite plane will undergo deformation. So, mainly this will show folding of the succession. Whereas this portion is showing your extensional cracks or fissures. So, in rotational slide, material moves suddenly along a curvilinear plane or a spoon shaped plane. It is also referred as slump. Slumps are defined as non-bedrock deposits. So, you will not have bedrock that moves downwards along a plane along which the rotation of the material will take place. Hence, we designate this as a rotational slide, because the material has been rotated along this one. The example of the rotational slide with multiple scars, that means that there are multiple planes along which the movement has occurred. Another example of that, so rotational slide in total, if you categorize, then what you are having is one is the crown with cracks at the top, second is the main scar, and third is relative slide blocks along the definite spoon shape surface, minor cracks which will be seen in this portion, and then you have 5 is the main body which is, and then transfer tensional cracks which will be seen here, and the toe area. So, this toe area will have the deformation under compression, and this region will have the extension. So, another example of the rotational slide, as I was talking about, that the toe portion will be under depression, and then multiple scars are indicative of multiple plane along which the failure will take place. So, there is another one which we say debris slide, the failure of unconsolidated material on a surface, a rock slide or rock fall movement of large rock blocks which will roll down in the nearby area, okay. And they are along they are also common along the steep slopes which has been shown here, okay, along the road cutting, steep river banks and lakes. So, this fall and the slide will be common in such areas where we are having steeper slopes, and this occurs because of the over stiffening of the slope for the construction of road or rail tracks. So, what we have learned is that we have the rotational slide which will take place along multiple scars. So, we have the one scar over here, then we have the another over here, and this will be moving along a definite plane. And what is happening in the toe here is this material is getting hold it. Now this is what the concept which we are talking about the rotational sides. So we have multiple scars, and at places we will have extension cracks, and here we will have some compression, and these are our definite planes here. Now can we see this example on surface? The answer is yes. Now this photograph which I am showing here is a very beautiful example which we experienced, and we were lucky to record this near to the Chandigarh city. So we have a cliff here, of course it's a river bank, the river is flowing over like that. Okay. So this is a channel of Gaggar river. And the material which is sitting here is very fine succession which belongs to Shivaliks. It's an older succession. So we have the river which is meandering here, and we have the floodplain on this side. But what we noticed was something unusual over here. This is the river bed along with so river bed is here. If you can carefully see this, okay. There is some sort of an elevation between this point and this point here, this point and this point here. This is up, this is down, this is up, this is down. Now usually such type of displacement of the surface we see along this line. I will draw just the line here. Usually we see such type of deformation of the displacement of the surface when there is any tectonic movement. So you have an horizontal surface like this, okay, and if there is a deformation under compression, then what you see is that some portion is warped. So this change in elevation could be related to the compression, but this was nothing to do with the deformation or active deformation in the Himalayan region. So let's see some close up of this and what was the reason for this river bed as well as the floodplain getting displaced along this line. So this is the surface or the toe of the landslided material. Close up of that, you can see almost the displacement or the material which is rided over the surface. This is the present day surface, and this material has rided over that. Okay. So there was some displacement, there was deformation, and the displacement of the surface, if you take, is almost like 1 meter and more than 1 meter. So what was the reason for this? We tried to gather and identify and understand that what exactly happened here, and this is a very typical example of your rotational landslide. So as we told that we understand that the rotational landslide at the toe portion will have deformation, but if you go towards the crown or the top part of the slope, then you will have an extension. So we looked for that, and this is what we found. So there were extensional cracks, we were having scars. These are the scars here, there is another scar here, and then we have an extensional cracks over here. So these are all extensional cracks. So there was a slip along a hidden plane which we were not able to see very clearly in the section, because unless and until you are not going to open the section, you will not be able to see the planes. But of course, these are all scars which explained that this was a typical rotational slide, and the material which we saw here was very fine deposit. And the reason which we gather was that there was a very long spill of a very long, we can say, dry spell in this region, and depending on the material, which has the different properties which can absorb water and swell, that is typical of clay, which we were talking in the previous couple of slides in the previous lecture, and they have the capability of shrinking. So they either shrink or swell. So this shrinking resulted into the extension and facilitated the slide along a hidden plane. So this hidden plane resulted into the rotational slide. So what we saw is that we were having an extension in the upper side, and the movement which occurred along this extensional cracks resulted into the deformation in the riverbed. So this was what we were looking at. The change in the elevation was because of the rotational slide close to Chandigarh area. Translation slide, movement parallel to plane of weakness. That is what we were talking about on that day, that if we are having geological structures which are having a definite plane or bedding planes, that can result into the landslip, and this can occur when you are having inclined stratified deposits. So as in thumb rule, all deposition will take place in horizontal fashion. So you have the different grain size and you have all material, but because of the deformation in some of the regions, you will find that they are, if you fold this, then what you see is that you are having the slope. So inclined surfaces along definite, if I put here this one sand, and you are having clay bed here, and then you have a sand here. So this portion, if you take, and you are having the inclined surface. So if you are having an inclination, and if you are having in stratified deposits, then it is quite likely that that portion may slip. So if you look at that, there is a movement along a definite plane. So these are bedding planes along which, if they are having an inclination, there is a likelihood of having the slip. I will stop here and then we will continue in the next lecture. Thank you so much.